We've all seen those movies before. Those ones where the asteroid is on a collision course with the Earth that will destroy life as we know it. And while those movies are never very realistic, an event like this did unfold in October of 2008, although it wasn't nearly as grandiose as a Hollywood blockbuster.
The recent object that re-entered the Earth's atmosphere over Sudan, 2008 TC3, was only about 6 feet across.
As part of our regular survey, we came across an object that was moving fast enough so that it was pretty much certainly a near-Earth object. And we have the capability of doing our own follow-up observations a few hours later. And so we duly reported that to the Minor Planet Center in Cambridge. The Minor Planet Center and JPL calculated that it would hit, 19 hours after the first observation.
So it was out beyond the moon, on its way into the Earth at about 12 kilometers a second. And so we found an object the size of a room at about 350,000 miles away. That's really a tremendous thing to be able to do. I think it's an interesting technological achievement.
While this particular near-Earth object was small enough to burn up in the atmosphere, it illustrates just how much material there is in space. Material the Earth comes in contact with on a regular basis. And that is where the University of Arizona's Catalina Sky Survey comes in.
The Catalina Survey started in 1998. The goal of our survey is to satisfy the Space Guard target of identifying 90% of the 1 kilometer or larger NEOs. The 1 kilometer objects now are reasonably understood in terms of their orbit distribution. And sometimes you'll have orbits that are such that you can't observe them very often, maybe once every 12 years or something like that. So we have a few to find yet. But the number is on the order of 950.
And that indeed is something the Catalina Sky Survey is well positioned to be able to do.
Each field is displayed here, and it tells you how many potential objects there are there.
We're very close to actually having met the goal, but we find objects below that size all the time. It's just that the smaller the objects get, the more difficult they are to discover because they're fainter. So the larger telescopes are needed in order to be able to find these fainter objects. And like we like to say, there's nothing like the human eye-brain combination to find very faint signals and very noisy data. So we can go deeper than many of the other surveys have done because they rely on automated systems, but for that final bit of analysis, we let the human eye and the human brain make that final decision.